Okay, starting with फर्स्ट एग्जाम्पल 14-1 तो हमने ऑलरेडी कवर कर ली है, जिसमें वो मुख्तलिफ फोर्सेज एक्ट कर रही थी जो आज हमने की है. उसके बाद स्टार्टिंग विद एग्जाम्पल 14-2 in which you have an automobile which has a weight of 3,500 pounds and it is traveling down this 10-degree incline road at a speed of 20 feet per second. So this car is traveling down the incline at a speed of 20 feet per second. If the driver jams on the brake, so suddenly the driver pushes the brake pedal, जिसकी वजह से causing his wheels to lock down, कि आपके पास जो कार के wheels हैं वो lock हो जाएंगे and the car is going to skid on this road, or because of the friction between the tires and the road, the speed of this car is going to decrease until it stops. So you need to find out कि how far his tires skid on the road before stopping. The coefficient of friction between the wheels and the road is given to you as 0.5. So आपके पास एक कार है which is traveling down the incline at a speed of 20 feet per second. Suddenly the driver applies brakes, causing his car wheels to lock. You need to find out how long this car is going to skid on this road before it is being stopped. Coefficient of friction जो है between the car tires and the road is given to you as 0.5. So अगर broadly मैं इस problem को देखूं, so कार की speed यानी velocity यहाँ involve है जो कि 20 feet per second है. उसके अलावा किसी distance s तक ये skid कर रही है, it means कि s जो है वो involve है, और साथ साथ फोर्सेस तो इन्वॉल्व होंगी, फ्रिक्शन इन्वॉल्व है, वेट इन्वॉल्व है. सो आपके पास एफ, वी और एस तीनों चीजें यहाँ इन्वॉल्व हैं. सो अगर आप तीनों काइनेटिक्स के प्रिंसिपल पढ़ चुके होते, आपको स्टेटमेंट पढ़ने के बाद द शॉर्टेस्ट मेथड टू यूज हियर, since F, S and V are involved here, so work energy principle is going to give you the shortest solution. Although this problem can also be solved using the equation of motion, but since F, V and S are being involved here, so work energy principle would give you a more direct solution as compared to the equation of motion. Is this point clear to all of you?
Yes, sir.
Okay, now first of all, drawing the free body diagram of this car. कि अगर मैं इस कार की free body diagram बनाना चाहूँ, तो ये मेरी एक्सिस हैं जो मैंने डिफाइन की हैं. से दिस इंक्लाइन एक्सिस को मैं अपनी x एक्सिस कह देता हूँ. So this incline axis is being termed as x axis. Perpendicular to that incline axis is basically my y axis. Okay, now showing the various forces which are acting on this car. One is going to be the weight of this car, which would be acting vertically downward. Then once you remove this inclined plane, you are going to get a normal reaction force acting in this particular direction. So these are the two forces which would be acting on this car. Is there any other force that is acting on the car? It is the friction between the tires and the road. So in what direction that force of friction act?
Upwards the incline.
Upwards the inclined plane.
So up that inclined plane, you are going to have this force of friction, Ff. So these are the three forces that would be acting on this car. So आपके पास ये तमाम forces जो है वो यहाँ involve हैं. As far as the axis angle of W is concerned, it is going to be 10 degrees with respect to the normal axis. So ये आपके पास free body diagram जो है वो complete हो गई है. Okay, so let us say कि this is my position 1 जिसके ऊपर brakes apply किए जाते हैं, and this is my position 2 जिस पे आके कार जो है वो रुक रही है after covering a distance of s on this inclined road. So position 1 is the position where this car is traveling at 20 feet per second and the brakes are being applied. Position 2 is a position where this car stops on this inclined road. Okay, एक और चीज जो मैंने आपसे कल शेयर की थी वो ये कि जो वर्क एनर्जी प्रिंसिपल है, since work is a scalar quantity, energy is a scalar quantity, so this work energy principle जब आप apply करते हैं, it is not going to be applied along some axis with reference to some coordinate system. Rather, since both work and energy are scalar quantities, so you apply this work energy principle or conservation of energy principle between two positions. Here these two positions are shown to you as position 1 and position 2. इसके मुकाबले में अगर हम equation of motion की बात करें तो since equation of motion is a vector equation, so वो equation आप हमेशा किसी ना किसी axis के along कोई coordinate system में apply करते हैं. इसके मुकाबले में work energy चूंकि scalar quantities हैं, so it is going to be applied between two positions rather than along some axis. Okay, so we are going to apply the principle of work and energy on this car between position 1 and position 2. So applying the principle of work and energy, it says that the initial kinetic energy of the car plus work done by all the forces which are acting on the car between position 1 and position 2 should be equal to the final kinetic energy of the car. So this is the principle of work and energy. We are going to evaluate each and every term one by one. First of all, starting with the initial kinetic energy. What is the initial kinetic energy of this car?
Half mv square, V20 है sir.
Half mv square, so v is 20. What about m?
3,500 pounds.
So is it m?
Sir, वो तो weight है ना, उसको divide करना है.
So 3,500 को 32.2 पे divide करेंगे, so we will get the mass of this automobile. So half m20 square would give us the initial kinetic energy of the car. What about the final kinetic energy? What is the velocity of this car at position 2?
0.
So since the velocity of this car at position 2 is 0, so accordingly the final kinetic energy of this car at position 2 is going to be 0. So this term T2 would be equal to 0. Okay, now since here the force of friction is also involved, force of friction by formula किसके बराबर होती है?
So normal reaction into coefficient of friction.
Okay, mu NC के बराबर होती है. So do you know the value of NC here?
सर निकाली जा सकती है.
कैसे निकाली जा सकती है?
सर W cos 10 करेंगे तो वो NC के बराबर ही होगी.
So कौन सी इक्वेशन आप अप्लाई कर रहे हैं?
सर वर्टिकल फोर्सेस जो वो इक्वल होंगी ना तो.
So I am basically applying the equation of motion. देखिए टेक्निकल टर्म्स में बात किया करें. So I am applying the equation of motion on this particle along the y-axis. So summation fy equal to 0 since the particle is moving along the x-axis, जो मेरी x-axis define हुई हुई है, that is along the incline. So summation fy would be equal to 0. That will give me nc to be equal to w cos of 10. ठीक है, so w cos 10 मेरे पास nc आ जाएगा. अब मैं force of friction जो है वो निकाल सकता हूँ. Okay, now coming to the forces which are going to be involved in this summation u1 to 2. Work done, कौन सी forces work done की तरफ contribute कर रही होंगी अगर मैं free body diagram को देखूं?
force of friction
और
weight.
NC के हवाले से क्या ख्याल है?
सर वो तो perpendicular है.
So there are only two forces that would be contributing to in this work done term. One is the work done due to weight, since weight is being vertically displaced between position 1 and 2. The other one is the force of friction, जिसकी वजह से work आएगा. As far as the work done due to NC is concerned, since NC is acting perpendicular to this displacement, so it should not be contributing towards the work done term. So अगर मैं broadly देखूं, आपके पास work done due to weight आएगा और आपके पास work done due to force of friction आ जाएगा. ठीक है? Okay, now evaluating each of these terms one by one. Work done due to weight, as per our previous discussion, it would have a magnitude of W times delta Y, isn't it?
Yes sir.
Okay,
Yes.
what is delta Y here?
20 sin 10.
थोड़ा सा और से देखिए मुझे बताएं.
सर S sin 10.
ये 20 वाला कौन था?
सर वो velocity से.
Okay, so delta Y is basically S. It is basically S into sine of 10, isn't it?
Yes sir.
Okay, so the magnitude of work done due to weight would be W into S sine 10. Should it be positive or negative?
Positive sir.
Because this S sine 10 is acting downward, weight is also acting downward, so the work done due to weight is going to be a positive quantity W into S into sine 10. Is this thing clear to all of you?
Yes sir.
Okay, coming to the next term of work done due to this force of friction. Okay, what should be this work done due to force of friction? It is going to be force of friction, which is mu nc. ये तो force of friction होगी. Work done के लिए मैं क्या करूँगा इसको?
S से multiply.
So I'm going to multiply it with displacement
Into
S.
S.
So mu nc into S is going to be the work done due to force of friction. Should it be positive or negative?
Negative.
Negative.
Since friction force is acting up the incline, displacement is down the incline, so the work done due to force of friction is going to be negative quantity. So overall, if I take a look at this equation, कितने unknowns हैं आपके पास?
Sir, S.
Only one thing is unknown to you in this equation, that is this S. So once you solve this particular equation, you are going to get the value of S to be equal to 19.5 fit. Is this point clear to all of you? हमने पहले NC find out किया, which is W constant. Then we applied the principle of work and energy, work done due to weight, work done due to friction force with a negative sign. It will give us the value of S to be equal to 19.5 fit. Clear है? कोई confusion, कोई query जो आप पूछना चाहें?
Clear.
Okay, let me ask you one question. What about instead of using this principle of work and energy, I'm going to use the equation of motion. Can I solve it using the equation of motion?
Yes, sir.
So equation of motion में apply करूँगा along the x-axis, y-axis के along तो already मैंने apply कर दी है. So applying it along the x-axis, summation fx equal to max. The forces which are acting along x-axis is going to be the component of weight, which is w sine of 10 with a positive sign. क्योंकि w को जब आप resolve करेंगे, so this is the component which is acting towards the positive x-axis, and force of friction which would be acting towards the negative x-axis. So w sine 10 minus mu nc should be equal to ma. तो आपके पास तमाम चीजें मौजूद हैं. So once you solve that equation, you will get the value of a to be equal to say capital A मीटर पर सेकेंड स्क्वायर. सो एक्सेलरेशन की वैल्यू आ गई, हमें s चाहिए. हाउ वी आर गोइंग टू रिलेट दिस a विद s देन?
देखेंगे कि एक्सेलरेशन कांस्टेंट है तो सर वो कांस्टेंट इक्वेशन ऑफ मोशन यूज करेंगे.
अच्छा, सबसे पहली बात, हाउ यू हैव जज्ड दैट दिस एक्सेलरेशन इज कांस्टेंट?
सर वो फोर्स इज कांस्टेंट है, m भी कांस्टेंट है.
ओके, सो इस केस में m कांस्टेंट है और w भी कांस्टेंट है और nc भी कांस्टेंट है. सो इट विल गिव यू a to be equal to a constant thing. So acceleration constant आ गई. अब constant acceleration के साथ आप क्या करेंगे s से relate करने के लिए?
तो सर वो फॉर्मूला यूज करेंगे तेरे इक्वेशन ऑफ मोशन
without involving time variable. So v square equal to v naught square plus 2a s minus s naught. ऐसे ही है?
Yes sir.
तो आपके पास ये s minus s naught एक तरह से वो डेल्टा s या s है. a आप फाइंड आउट कर चुके हैं. कांस्टेंट एक्सेलरेशन v नॉट कितना था आपके पास? दैट वाज 20 फीट पर सेकेंड. v आपके पास 0 आ गया. सो वंस यू सॉल्व इट यू विल गेट s to be equal to 19.5 फुट अगेन. सो इसको आप दोनों तरीके से सॉल्व कर सकते थे. अगर आप चाहें इक्वेशन ऑफ मोशन से कर लेते, लेकिन चूंकि f v और s का डायरेक्ट रिलेशनशिप आपको चाहिए, वर्क एनर्जी प्रिंसिपल आपको दे रहा होता है. सो आपने सिंगल स्टेप में सोल्यूशन निकाला. यहाँ आपको ये 2 स्टेप्स करने पड़ते इन ऑर्डर टू फाइंड आउट द सोल्यूशन. इज दिस पॉइंट क्लियर टू ऑल ऑफ यू?
सर
जी
सर ये s cos थीटा नहीं होगा?
क्या चीज?
सर क्या ना, जो हमने ax जो निकाला है वो ऐसे फीट पर सेकंड स्क्वायर में होना चाहिए.
सॉरी, मीटर पर सेकंड, सॉरी यूनिट्स मैंने गलत लिख दिया. इट इज गोइंग टू बी फीट पर सेकंड स्क्वायर. ओके
सर ये जो आपने फार्मूला में s माइनस s नॉट लिखा है तो ये s cos थीटा माइनस s नॉट cos थीटा नहीं आएगा?
नहीं, देखिए cos इसलिए नहीं ले रहे बिकॉज द एक्सिस व्हिच आई एम डिफाइनिंग हियर आर x axis to be the axis of this incline and y axis are being defined perpendicular to that x axis. So x axis मेरी conventional x axis नहीं है, ये down the incline axis को मैं x axis कह रहा हूँ.
Okay, sorry.
Okay, any other question which you want to ask regarding this example 14-2?